And then let's do another one. Let's say a red one. And then a purple one. And then we have, let's see what we got left over, brown. As I'm looking at these sides, if I rotate each one of these just a little bit, if I turn that much for the brown one, then this much for the blue one, and then I keep going and keep turning, I always wind up back at 360. I wind up right back where I started. So if I'm spinning on the brown, I went to here, then the blue, I went about to here, and then green, I went to there, then red, and then purple. So I have this full rotation. So every time I travel around the exterior angles, I do a full rotation. That's where I get the idea that the sum of the exterior angles is 360. So now this one, it says it's a regular pentagon. Well, if it's a regular pentagon, let's go ahead and redraw this, maybe just a little bit better. We can stretch it out just a little bit. Each of those should be about the same. How many are there total? There's 5. So that tells me that I can take the total 360, divide by 5, and I get each one. This next one's almost too easy. It's ridiculous. If I have a quadrilateral and it's regular, actually it doesn't matter if it's not with a quadrilateral, but this one is. And I'm trying to measure the exterior angles. I got this one, this one, this one, and this one. This makes 4 90-degree angles. That's too easy. Another way of just following along the same pattern, though, it'd be 360, which is the total of the exterior angles divided by 4, and that's how I get 90. If I didn't want to draw the picture and just use a straightforward formula, this is what I would get. Now this one's a little bit different. If you notice, we have a lot of different angles in here. Some of them are the same. 5s are the same, 7s is the same, 8s is the same. So we have a little bit of balance, but not everything is the same. So let's start by trying to figure out how much the total interior angles are in here. If I go from B to D, and B to E, and B to F, I split this up into 1, 2, 3, 4 triangles. So that tells me that I have 4 triangles available. Let's step this back a little bit. So I have 4 triangles available. I got 6 sides, 4 triangles. So it's going to be 4 times 180 is the total. So to find the total, 4 times 180 is actually 720 is my total. Well, I know that my total is all of these added up as well. So I got 8s plus 8s, 7s plus 7s, 5s plus 5s. So I got 16, 14, and another 10. So I'm going to add all that together. 10s plus 14s plus 16s. Well then, let's put those together. This would make 30 plus another one, that's 40. So 40 times s equals 720. So I got to figure out what s is and then try to apply that to the measures inside of this polygon. So if I divide by 40, then I get 4 goes into 72. Well, wait a second. When we look at this, 2 goes into 72 36 times. So 4 goes in 180 times, or 18. So S equals 18. Over 1. Now if I know that S equals 18, what I want to try and go for is finding each one individually. Well, 7 times 18 is going to be this one. 5 times 18 is going to be our angle F. And 8 times 18 is going to be like our angle D, and A as well. And then for E and B, those match, and C and F match. 5 times 18 is 90. 7 times 18 is going to be 90 plus 36. So if I add 36 to 90, that's going to give me 126. If I add another 18 to that, which would give me let's see if we add 18 to this, how much would that be? We have a 4, carry the 1, 144. So that's 144 for D. This is also 144 right here. Up here for the 7, this is 126. And for the top one, it's 90 degrees. There we go. So what are we looking at in general? We got the ideas of irregular versus regular. We got polygon versus not. So is it a polygon? Is it regular? Is it convex or is it concave? How do we know the difference? Then we got to know how to find interior angles versus exterior angles. If you guys are comfortable with those, give yourself a happy star.